Let's jump right in. Today, we're taking a journey into the actual architecture of reality. We're looking at the profound mysteries of the quantum vacuum and the incredibly strict rules of the strong interaction. We'll also be introducing a really fascinating geometric interpretation of why our universe holds together the way it does. It's an elegant, almost cinematic mystery. So let's get started. Now, let's look at something familiar first, the electron. An electron has an electric charge, and that charge can just exist as a free particle. It can stand completely alone in public, openly exposing its charge to the rest of the universe. But contrast that with a totally different type of charge, carried by quarks, called color charge. The strange, deeply anomalous thing about color charge is that you will literally never see it isolated. The field behaves completely differently. Section 1. The anomaly of color, the charge that cannot appear. Let's get into it. So we need to completely reframe how we think about particles existing. Normally, we isolate things to study them, right? Molecules, atoms, electrons. You isolate an electron in a vacuum, and there it is, a loose public object. But a quark? Quarks carry this property called color charge, and yet no isolated quark has ever been seen by human eyes, or even our most advanced detectors. It simply does not appear as a loose object. No way. Which brings us to this absolute uncompromising mandate of the physical universe. Color must close. It's a mandatory rule. You cannot have an open, loose end of color charge just wandering through the universe. It has to resolve. It has to close. Moving on to Section 2, the grammar of QCD, or closed accounts. Let's look at how physicists actually describe this mathematically. We call it the grammar of quantum chromodynamics, or QCD. First off, let's be super clear. When physicists say color charge, they are definitely not talking about red, green, or blue paint or anything your eyes can see. That's just a naming convention. Color charge is a strict mathematical property of the strong interaction, simply used to keep track of the mechanics of quarks. Here are the established rules in the standard model. Quarks carry this color charge. Gluons mediate or carry the strong force between those quarks. And because of that strict rule we just talked about, quarks are forced to combine into perfectly balanced, color-neutral structures called hadrons. The visible world, literally everything around you, is built entirely from these closed accounts. And the final rule remains undefeated. Isolated color is never observed. Section 3, the mechanics of confinement, the stretched cord. Okay, but what if we try to break the rules? What if we build a massive particle accelerator, pump in unbelievable amounts of energy, and try to rip two quarks apart? Well, let's compare the fields. With an electric field, pulling charged particles apart makes the field spread out smoothly and fade, kind of like a mist dissipating. But the strong field? It does the exact opposite. As you pull quarks apart, the strong field does not thin out. It concentrates. It stores the energy being applied, and it tightens, almost like a stretched rubber band. The further apart they get, the more the tension builds. Let's walk through this process, which is known as the flux tube, step by step. Step 1, you grab two colored quarks and pull them apart. Step 2, the energy in the connecting row between them rises exponentially and tightens. Now, your intuition probably tells you the cord should snap and leave you with two free quarks, right? Actually, no. In step 3, the energy in that cord becomes so intense that it condenses and literally creates a brand new quark-antiquark pair right out of the vacuum, which leads immediately to step 4, color-neutral closure is restored. The ends just snap to the newly created particles. It's a completely mind-bending reality. Instead of breaking a quark free, the universe uses that immense energy to force new closed systems into existence. You do not extract free color. You get more closure. The universe will literally create new matter before it ever allows a single quark to exist in isolation. Section 4, the GEM hypothesis and the vacuum clearinghouse. This incredible mechanism opens the door to some seriously fascinating exploratory territory. We're stepping beyond the established physical grammar of QCD to ask a deeper question using a framework called General Emergence Mechanics, or GEM. GEM asks, what if physical confinement isn't just a force pulling things together? What if it can be read geometrically as a deeper admissibility rule of reality? Essentially, is the universe running a strict audit on what is even allowed to exist? In this framework, open color is unfinished debt. Think of reality as a public ledger. Just like an accountant would absolutely refuse to publish a ledger with a massive unbalanced debt, the geometric rules of the universe will not let you post open color to the public ledger of reality. It's an unfinished route. The vacuum is the clearinghouse. That is a really powerful metaphor to hold on to here. The vacuum, the seemingly empty space around us, isn't just nothingness. In this framework, it actively audits reality. It's a clearinghouse that rigorously inspects every single route and strictly refuses any unbalanced, unfinished color lines from passing through into existence. Section 5. The geometry of reality. Settled accounts. Let's see how this clearinghouse metaphor perfectly maps onto the actual matter in our universe. In the standard model, a baryon, like a proton made of 3 quarks, isn't just particles sitting together. In GEM, it translates to a color-neutral settlement. A meson, made of a quark and an antiquark, is a closed account, and the broader physics term color singlet maps flawlessly to an admissible closure. The established, stable particles of QCD are essentially settled geometric debts. The crucial takeaway here for how we view physical objects is this: matter persists only where color routes close. The objects in your room, the device you're using, even your own body, they are only allowed to persist in reality because their fundamental internal routes have successfully settled their debts. They pass the vacuum's audit. Section 6. Beneath the physics. A deeper geometric question. Now, we need to be incredibly clear here to maintain scientific rigor. This speculative framework is not a replacement for QCD, a geometric question beneath it. Quantum chromodynamics remains the undisputed, highly successful working theory of the strong interaction. It gives us the precise grammar of particles. GEM doesn't dispute that grammar at all. It just asks what the underlying paper is made of. And this brings the two ideas together perfectly. QCD gives us the physical mechanics, the flux tubes, the strong fields, the particle creation. But philosophically and geometrically, QCD may be where the vacuum says, color must close. The incredibly strict physics of confinement is simply the physical manifestation of this relentless, deeper geometric audit, which leaves us staring at a beautifully sharp, exploratory question. Does reality permit only those color routes that can close? Are the laws of physics essentially just a set of filters, burning away the impossible and only allowing balanced, finished geometries to emerge into our universe? Ultimately, it all comes back to this unyielding mathematical truth of the vacuum: no free color. That is the ultimate boundary of our visible reality, the unbreakable rule ensuring the stability of the universe. As we wrap up this explainer, it totally reframes how we think about existence itself. Matter may not be what possibility becomes, matter may be what possibility is allowed to settle. It forces us to see the universe not just as a collection of stuff, but as a rigorously audited ledger of settled geometries. Hopefully this deep dive has sparked your curiosity about the invisible rules holding our reality together. Thanks for learning with me today, and keep exploring.